The shocking truth about the replacement of James Webb. Have you ever wondered about the mystic beauty of the universe? Yes, you have, haven't you? Just like you, when the world started to develop in the late 80s in the field of astronomical space, scientists wondered about the existence of the universe, and soon we found a theory of the Big Bang, which, till now, is the most accepted theory of the creation of the universe. Late in the year of 2021, NASA launched the James Webb Space Telescope on December 24th in the hope to find more about the universe and prove the Big Bang theory of the existence of the universe, which is considered the replacement of the Hubble Space Telescope and considered to be the most powerful telescope to date. In today's video, we will reveal the shocking truth about the replacement of the Hubble Space Telescope with the James Webb Space Telescope. The James Webb Space Telescope, named the second child of NASA last year, has entered its orbit around the Lagrange point 2, or L2, a million miles from Earth. A magnificent celestial telescope will orbit the Sun and orbit around the Earth. At that time, the Hubble's telescope was about 340 miles away. So does the James Webb Space Telescope replace the Hubble Space Telescope? Because the JWST does not cover the same types of light that Hubble can make, it does not really change Hubble's abilities. But wait. What if I would say that James Webb also is on the track of replacements within a decade or two? What will be the agency's next gigantic space telescope? The mechanism that will shape scientists' exploration in the 2040s? The answer is still years away, but NASA has financially supported deep analysis of 4 potential projects so that the agency can better assess the dangers and opportunities associated with each proposal. The Large UV Optical IR Surveyor is one of those mission concepts, or Luvoir. If built, the telescope could address a wide range of scientific issues, but its primary focus would be on providing scientists with the most realistic view yet of exoplanets that appear to be like Earth, but are actually, well, nobody knows. If Luvoir becomes a reality, its primary contribution to the field will be to provide a detailed view of planets that currently meet scientists' bare-bones criteria for Earth-like planets. These worlds resemble our own in terms of size, mass, and orbit, if scientists know anything about them at all. However, Webb believes that scientists will be able to begin understanding how valuable our vibrant planet is with Luvoir observations of just 28 of those worlds. Luvoir would zoom in on such small rocky worlds and tell scientists what percentage of planets that appear to be Earth-like actually are, with surface water, an atmosphere, and growing organisms. Luvoir would generate spectra, breakdowns of the amount of light of various wavelengths coming from the object, rather than images for each of the worlds it studies. These spectra would allow scientists to identify the components on that world, revealing more about what's going on beneath the surface. The primary goal of Luvoir would be to discover and study alien planets in order to better understand the ubiquity of life. But the telescope would also discover a plethora of other worlds. Luvoir's scientists and engineers have turned their Webb experience into 10 recommendations they believe will keep their project on track. Not all of those strategies are completely within the team's control. Some would necessitate a review of NASA's agency policies, and the Luvoir team is confident that if NASA chooses the project, the suggestions will help them avoid a similar fate. NASA says Webb is not a replacement for Hubble. Instead, its follower and its scientific inventions were inspired by the results of Hubble. Webb will primarily study the universe in infrared, while Hubble focuses mainly on light waves and ultraviolet waves. Webb's screen is much larger than Hubble's. Therefore, it can look back in time rather than Hubble. Also, Hubble was in a much closer orbit around the Earth than Webb ever will be. This is similar to what the Kepler Space Telescope mission did for exoplanets in overall. It discovered so many alien frontiers that astronomers could begin to understand the relative abundance of, say, massive planets orbiting very close to their stars versus small rocky worlds. We have no idea what the diversification of terrestrial planets will be like, said Roberge. Venus, Earth, and Mars are the planets in our solar system, but first and foremost, they are very different from one another. Second, I'm sure there are other options available. If scientific researchers can conduct those evaluations on at least 28 small rocky worlds that turn out to have atmospheres and find no signs of life, the Luvoir team believes that less than 10% of planets with the size and orbital attributes of Earth host life. What are the goals of Webb's mission? What does NASA want to achieve from the new replacement of the Hubble Space Telescope? Webb is sometimes described as a time machine, meaning in a sense. But why? Because light from distant objects travels at a moderate speed, we see them as they were in the past. Hubble has shown us galaxies as they did millions of years ago, but the JWST will be even more sensitive. NASA hopes it will see all the way back to the formation of the first galaxies about 13.6 billion years ago. And Webb also has the advantage over Hubble's visual band telescopes. As the universe expands, light from distant objects is stretched, which increases its wavelength. This means that the light emitted from the visible waveband reaches us in infrared, and the JWST band has been upgraded. One of its first tasks will be a survey called Cosmos Webb of the farthest galaxies in space to examine conditions at the beginning of space. Also, thanks to Hubble's beautiful images, many people know what galaxies look like. Large clusters of stars, usually arranged in a circular pattern. But these are usually close galaxies, so they are mature ones, meaning that they are not new galaxies, they have been here since the formation of the Milky Way. Hubble's delightful captions given to the oldest galaxies suggest they are too small and look ugly. At present, no one knows how these galaxies came to be or how they came together to produce the massive galaxies we see today, according to the California Institute of Technology. It is hoped that Webb will be able to answer similar questions with its in-depth view of the first universe. Another well-established feature of galaxies is the presence of large black holes among most of them. In the first atmosphere, these black holes often activate bright galactic nuclei called quasars, and Webb is designed to study 6 of the farthest and brightest examples of these. The galaxies of the universe began a long time ago, and it has changed little by little since then. But that is not the case with the stars inside them, which move in the same cycles as living creatures. They are born, developed, grow old and die, and the remnants of old stars contribute to the raw material needed to make new stars. Most of these processes are well understood, but there are still mysteries surrounding the actual birth of the stars and the disks of the planet they may form around them. This is because the newborn stars are actually covered with dust, which is a standard telescope that uses visible light. But all this dust will be exposed to the infrared waves used by Webb, so NASA hopes it will eventually unravel the final secrets of star formation. This may teach us something about the origin of our sun and the solar system. Once fully operational, scientists believe that the telescope will be able to look back in time some 100 million years after the Big Bang. And not only do scientists think they can look back at galaxies since then, but they also think they may be able to determine the shape of these galaxies. The information and the new discoveries of the universe could prove beneficial to NASA and will also provide us with the secrets of the universe, which could help in the new missions of NASA. That's all for this video. If you have any queries or suggestions in your mind, feel free to put them in the comment box. And if you liked the video, please like, share, and subscribe. And thanks for watching!